we have learned about reflection. Now we are going to learn about refraction. Right, the heading called refraction. Refraction. So far we have learned about refraction. Now we are going to learn about refraction. What is the difference between reflection and refraction? Difference between refraction is what? Reflection means touch it will return back. Refraction touch the next medium. That medium is what type of medium? Transparent medium. Water, glass, transparent medium. So there are certain conditions for reflection and refractions, but for example, in properties of fluids you will learn about, right? Viscosity. So here we call it as denser. Denser means thicker. You can consider like honey, oil, example, water. Water is more thinner than oil. Oil is thicker. Oil examples are denser medium. Denser medium, rarer medium. Two medium, what type of medium? Transparent medium. Transparent means what? It will passes the light. This is transparent. This is transparent. For example, if you are taking oil, will be here and water, but oil is transparent. Clear oil is transparent. Clear water transparent. So if I am keeping, so what will happen? The rays are transmitting. Transmitting means incident ray. Rays are going from the object. These are called incident ray. Okay, so there are enormous number of, any number of incident rays will be there. If a ray, now this is going from where? Denser medium. Then denser medium to rarer medium, if a ray is going, it's already, it is going from, if a ray is moving from denser medium to rarer medium, opposite case, another case. What? Bending away from the knob. Here, angle of refraction. Angle of incidence greater than angle of refraction. Opposite. Refraction greater than angle of incidence. So refraction means this ray can go to the other medium in a simple way. So far we have learned about a plane, or if it is in a concave mirror also, we will put it like this. This is called, this is a painted area. It's not there. Area. If an incident ray is coming like this one, after reflection it will pass like this one. So we have after reflection. So reflection there means it is coming back to the same medium. But here it is not coming back to the same medium. It is moving from one medium to another medium. That is called refraction. Okay. Refraction means going to the next side. That's all. Reflection means coming back to the same side. Here one important, these are some general information. This one medium, whether it is a rarer, index is the measure of thickness of the medium. Thickness is more. If for example glass in the refractive index and the value normal at 1. What? 4/3. Correct? So water is more thinner than glass. So refractive is actually the thickness. Index Snell's law, n1 into sine of angle of equal to else law. Understood? This already you have learned in schools, right? So n1 into sine I equal to a forward, but based on that we will do one another. Point number 1. This is point. I know C is equal to what called F lambda generally. Correct? C is equal to F lambda. So if a ray is moving from A to A medium, then parameter in frequency parameter. So frequency is not changing. Here C is a constant parameter. Correct? 3 into 10 8 meter per second. So if I am taking these equations, then N1 divided by N2 is equal to C by V1 divided by C by V2, which is equal to V2 by V1. Third point. Fourth point is with respect to F by, not F by, C by V. V is what? V can be written as F lambda. C is constant. F lambda. So I can say N is proportional to 1 by wavelength. Because F is constant, C is constant. F is depends on the color of light. Okay, if it is white means F is fixed, if it is blue means white is fixed. So here also I can written as N1 divided by N2 is equal to, how it should come? Lambda 2 divided by lambda 1. This all the formula we will use interchangeably, depends on the question. Okay, so let's summarize 3 things. What we learned? Refraction. Refraction means going from one medium to another medium. Either it is from denser medium to rarer medium, or it is from rarer medium to denser medium. What is called Snell's law? N1 sine I equal to N2 sine R. This already you know. N equal to standard equations for a refractive index, generally get as C by V. C is the velocity of light, 3 into 10 power 8. V. Then N1 by N2. If you are considering like a 2 medium, then there is a 2 refractive index. There are 2 velocities. For example, in the first medium it is traveling with a velocity v1, second medium it is traveling with a velocity v2, because C is fixed. So N1 by N2 is equal to C by v1 by C by v2. C cancel, v2 by v1 will come. Another way of writing this one, I know V, this can instead of C I can write as V also, because C is, I substituted here N is equal to C by F lambda. C is fixed, F is fixed for a light. Then lambda, wavelength will be changing. So N is proportional to 1 by lambda. Okay, 1 by lambda. So N1 by N2 is equal to, in the opposite way, lambda 2 by lambda 1. We will write all these points. Okay, below it is the movement of light when it passes from, it is the movement of light when it passes from one medium to another medium, having different optical density, Next point, optical density is measured using refractive index. Optical density is measured using refractive index, in bracket n and some textbook using n, some textbook will use mu. Both are same. Okay, wherever you are coming you can accordingly, n or mu. Next one, standard of refractive index. Next point on heading alla, n equal to c by v, equal to c by v. Okay, next point. When a ray is moving from denser medium to medium, when a ray is moving from denser medium to rarer medium, it is bending away, from the normal. Then draw the first diagram. It is bending away from the normal. Then it is bending away from the normal. You don't want to draw this multiple lines, but only this line is important, right? IR. IR very line mattum po. This first diagram. Ray is moving from denser medium to rarer medium. Ray is bending away from normal. Then next point, opposite. When the ray is moving from a rarer medium to denser medium, the ray is moving from rarer medium to denser medium, refract bending towards the normal. Refracted ray bending towards the normal. Refracted ray bending towards the normal. Then draw the second. This one. Finished. Then next, if n1 is the refractive index of a medium, if n1 is the refractive index of the medium, and the velocity of light in that medium is v1, in that medium is v1. Then again, for the second medium, refractive index n2, velocity v2. And for the second medium, refractive index n2, velocity. Then write n1 by n2 equal to same thing, c by v1 whole divided by c by v2, which is equal to v2 by v1, Then write v is equal to f lambda. Next point, v is equal to f lambda. F is constant for a particular color of light. F is constant for a particular color of light. F is for a particular color of light. So V is changing. F is constant for a particular color of light. So V is changing due to the changes of lambda. So V is changing due to the changes of lambda. So changing due to the changes of lambda. Then write n equal to c by f lambda. N equal to c by f lambda. N is proportional to lambda 2 by lambda 1. N1 by N2 is equal to lambda 2 by lambda 1. This formula is important. This one of course it is, but yeah, we'll see. Write one question. Speed of light, right? Speed of light in water, speed of light in water and glass are 2.25 into 10 power 8 meter per second. 2.5 into 10 power 8 meter per second and 2 into 10 power 8 meter per second respectively. Find the refractive index of glass and water. Water and velocity is given, glass and velocity is given. So refractive index of water is equal to, how will write? C by water. So C per second, 2.25 into 10 power 8 meter per second. So 300 divided by 225. You can simplify. 4 by 3. 1.33 4 by 3. Similarly, refractive index of glass is equal to velocity C by velocity at glass into 10 power 8 whole divided by 2 into 10. Answer is 3 by 2. Direct question, never ask. But to and bigger, you need to know these things. That is only reason. Okay, next question. This will ask, wavelength of light is, next question, wavelength of, this is understood, right? Simple. Wavelength of light is 4800 angstrom. 4800 angstrom in air. Find the wavelength of the same light. Find the wavelength of the same light in diamond. Find the wavelength of the same light within bracket, right? Find the wavelength of the same light in diamond within a bracket, right? Additionally, refractive index of diamond is 2.4. Refractive index of diamond is 2.4. What is the formula? Refractive index of diamond divided by refractive index of air is equal to, how I can write as wavelength of air, inverse relation, opposite both side. So of diamond. What is refractive index of diamond? Refractive index of air is 1. How much I told? 4800 angstrom. Wavelength in diamond. So lambda d divided by 2.4. So 4, 8. So cancel 2. Answer is become 2000 angstrom. 2000 angstrom. Next question. Not the next question. We have written Snell's law. No. Then write next head. Law. That's it. Then write the formula. Definition very neatly studied in school, right? So n1 into sine to n2 into sine r. A diagram or equation enough. Write a question, answer it. Find the angle of refraction. Find the angle of refraction and angle of deviation. Find the angle of refraction and the angle of deviations. Draw the diagram, then we'll see. Find the angle of refraction and the angle of deviation. I will tell you a couple of things. Angle of refractions and angle of deviations. Which law? Directly? Snell's law. Correct. So air in a what is the formula? Refractions. N1 air refractive index sine of root 3 into sine r. Sine 60 is root 3 by 2, correct? Is equal to root 3 into sine. Cancel r equal to 30 degree. R equal to 1 by 2 so r equal to 30 degree. Got it? What is the second part of the question? Angle of deviation. Angle of deviation means if because of the refraction the ray is bended, correct? If also it will happen to the ray. The ray will pass like this. Now from this path the ray is shifted. Delta has to find out. So with the you see with the equal 30 degree. So delta is what? So deviation. How much it is deviated from the fine. Next question. Find the Next question. Find the angle of emergence. This is completed up. The angle of emergence. Find the draw the diagram as well. Find the angle of emergence. Hmm? 30 degree. 30 degree. Good answer is it?
It will be inside, then it will be downside. So for both cancels, so 30 degree is safe.
How both will cancel it? Sorry, how both will cancel? Sorry, cancel in the period.
What it is?
Correct only. Think. This is medicine question now. Not recently, 2010 or 2009 or how 30 degree? Sorry, I will write. Else you will write. Okay, then I. N1 means 1. Equal to root 3 into sine r. R means this one. Okay.
Sine
By 2, 30 degree. Okay. So sine r is equal to 1 by 2. So r equal to 30 degree.
1/2.
Correct. So here this is 1 by 2 is equal to root 3 sine r. R sine r is equal to root 1 by 2 root 3. Correct alla?
Then that will be the incident angle for the next rays.
So incident angle means this is a normal ray. So what is the value of this one? This is the incident angle for the next ray. So what is the value of this one? This r you got sine r equal to sine. So this is it's correct. Then what is the value of this one? How same?
So that is the incident ray, the refracted ray become the incident ray for the emergent ray.
Correct. But this angle and this angle
No.
this is r. What is the value of this one? Say. How say? Same. Same logic. This is same means this is an isosceles triangle. That's the reason. Same. This is also r. Now I go equal to N2. N2 is air. 1 into sine of E. Root 3 into sine R. Already I got 1 by 2 root 3 into sine is equal to sine E. Root 3 cancel. Angle of emergence is equal to 30 degree. Are equal because isosceles triangle. Maths. Understood, right? Okay, then the next heading. Next heading is what? Real depth and apparent depth. Real depth and apparent depth. This is the pulse of next 2 hours. Done in the basin. Okay. I'll tell you an example. Suppose if you have a big bucket. A bucket full water. Then you put a coin. You can see, you can't see the full depth of the water. You feel like the coin is little lifted up. But what we have seen, the coin is not, if you put one coin to the bucket, the coin will go down and it will be there in the bottom. But if you are looking from the top, what you can see, coin is not exactly at the bottom. That's correct. Alpha lift pannittu irukum. So our original depth feel avadu. Similarly, if you are looking to a swimming pool, you will never feel the original depth unless until you are there. Correct? அது பார்க்கும்போது அது ஒரு ஃபீல் வராது, பட் உள்ள இருக்குமா ஒரிஜினல் டெப்த் இங்கன்னு ஃபீல் ஆகும். கரெக்ட் அல்ல? எக்ஸாக்ட்லி. ஸோ தட் ஒரிஜினல் டெப்த் இஸ் கால்ட் ரியல் டெப்த். Okay, and what we feel from outside is called apparent depth. Okay, we'll take some examples and then we'll see. For example, or will be here. Definitely that from the coin instant rays are coming out. Suppose I consider what medium to which medium. This is denser, rarer, so it is bending away from normal. Okay, and this is the original depth. I am putting as OD, original depth. Okay, but I feel the coin is not exactly here. If I am looking from here, the coin is at the exactly at here, coin is somewhere here. Our depth normal ray actually. Okay, now if you extended this reflected ray, this will meet at this point. This is the height you feel it is. When you are looking from here, you feel it is not here, you feel it is somewhere here. And this depth from the surface to this bottom, listen very carefully, this is called apparent depth. Okay, apparent means it's not the reality, virtual madri. So this is called apparent depth and the full height is called original depth. Okay, refractive index. Okay, now this is an angle of incidence, I. If this is I, this is also equal to I. Both are same, right? Opposite angles are equal in a triangle. And this is the refracted angle R. Then what is this angle also? This angle is also equal to R. Okay, now I am applying Snell's law. What is Snell's law? Here I am applying the Snell's law. For example, N2 into sine of angle of incidence means what? Sine I is equal to what is coming? N1 is here. I know N1 is 1. This because I want to write something later. N1 into sine R. Okay. This I angle normally this light rays very small. Normally small degree. Okay, it is not a bigger value. Practicality as well. In practical, this value is small value. Maximum 30 the 30 ku mele varathu. Okay, 30 is 0.5 ആണ്. അപ്പോൾ 30 ക്ക് കീഴെ വരുമ്പോൾ very less. Sin 0 is 0. Sin 30 is 0.5. അപ്പോൾ sin 30 to 0 എന്ന് சொல்லுമ്പോൾ 0.5 to 0. Very less value. Is small. If I'm saying I is small to tan I. This is a trigonometric relation. Sin can be approximated with approximate sine and tan are almost equal proportion കാരണം tan 0 ആണ് sin 0 ആണ് tan is increasing sin is also increasing but cos opposite ആണ് അതുകൊണ്ടാണ് സൈനും ടാനും കമ്പയർ ചെയ്യുന്നത് okay so this can for example this can be written as n2 divided by n1 equal to what is coming on the right side sin r by sin I. Sin R can be written as tan R divided by tan I. What is tan R from this figure? For example, R. What is tan R? Opposite side by adjacent side. X by D. So n2 divided by n1 equal to tan x by apparent x by apparent depth whole divided by tan I means this one x by OD x by original depth x and x will got cancels so how I can written further n2 divided by n1 equal to n2 divided by n1 equal to reverse level which means original depth by apparent depth this formula you have to remember many places you will use this one ODP. Okay, how to remember this formula? See, here is the object. Correct? From where you are looking? You are looking. Remember the formula. You will get confused while writing the examinations. In order not to confuse you, wherever the object is placed, object is here. Correct? This is object coin. Okay, so object is here. Object is the first two. Object വരുന്നത് ഫസ്റ്റ് where you are looking അത് സെക്കൻഡ് വരും ഒബ്ജക്റ്റിനാണ് ഇവിടെ ഇമ്പോർട്ടൻസ് സോ ഒബ്ജക്റ്റ് വരുന്നത് ഫസ്റ്റ് ന്യൂമറേറ്റർ ഓക്കെ ഒബ്ജക്റ്റ് ഉള്ളത് ന്യൂമറേറ്റർ ഫ്രം വേർ യു ആർ ലുക്കിംഗ് ഫ്രം വേർ യുവർ ഐ ഈസ് ലൊക്കേറ്റഡ് comes denominator then simply write OD by AD original depth by apparent depth now you remember later you will not remember okay so n2 of learning coin or fish or lot of questions will come normally from this area so wherever it is placed that is called n2 from where AD original depth is the coin this one understood then draw the diagram and write blah blah things finally this formula is required original depth real depth you can just draw the diagram and you can this is the things which we are going to use many places one more additional parameter I have to say this difference right this is called moment, then you can write. It is equal to what? OD minus AD. Just remember in case if they ask. Okay, so this is a shift you feel, correct? OD is the original depth, AD is the apparent depth. OD by AD. How many of you have written Amrita entrance examination last year? You have written, huh? The last year Amrita engineering entrance exam be there, right? The Amrita college is conducting separate exam. How many of you have written? No, nobody written, huh? Oh. Okay. This is finished. Normally why I am asking is like always they are asking one question from here every year. So far from first day to last day, every time they will ask one question. So written shift OD. Then write one question. What is the distance of the fish observed by the bird? What is the distance of the fish observed by the bird flying over the water body? Flying over the water body. The bird is at a height of 36 centimeter. The bird is at a height of 36 centimeter from the surface of water. And the fish is at a depth of 24 centimeter. And the fish is at a depth of 24 centimeter from the surface of the water. That's all. Fish is in the water body at a depth of over the water body, and the bird is at a height of 36 centimeters from the surface of the water. Bird is looking to the fish. Then how much distance the bird will see the fish? What is the distance from bird? What he sees the fish? What is that? What is that height? How much? Correct. How to do? First, ask such kind of questions, just to draw the diagram. Okay, this is an easy way to do that. So what is available will be here. Fish is available over here, right? And bird is available over here. So bird is at a height of how much distance away? 36 centimeter away. Then this is at 36 meters away, and the fish is located at a distance of 24 centimeters away. You know water body refractive index 4 by 3, which is 1. We use the formula N2 divided by N1 equal to original depth divided by apparent depth. N2 is the object located in the water. So what is this one? 4 by 3. So 4 by 3 divided is the other one. Correct? So it is what is the original depth? Fish is now at a depth of how much? 24 centimeter. So this 24 centimeter is known as original depth. And apparent depth may be somewhere here, that I don't know. I have to find apparent depth. So original depth is 24, apparent depth I don't know. Okay, so apparent depth into 4 by 3 is equal to 24. Apparent depth is equal to 24 into 3 by 4, 6 into 3, 18 centimeters. So I know the height is now, I got apparent depth 18 centimeter. So bird, how far away it is? From the bird. So from the bird, it is 36 plus 18, which is equal to 54 centimeter away. Clear, huh? And the next question. A bird flies over the water body. A bird flies over the water body. Over the water body. The bird height of 36 centimeter. Same question, Aishwarya. The bird is at a height of 36 centimeter from the surface of water. From the surface of water, and the fish is at a depth of 24 centimeter. At a depth of 24 centimeter from the surface of water. How far the fish sees the bird? How far the fish sees? Fish is now watching. Reverse opposite. Okay. Now fish is looking. 69, 1660. Okay, let me see. I don't know. I'll just do it. Now fish is looking the bird. Now change will be here. All things will be changes. She is looking the bird. So here your eye will come. Here your eye will come. The fish is your eye. So what is original depth? This is your original depth, 36 centimeter. You are looking from here. Depth. So N2 divided by N1. N2 is the place where object is. N2 here. N2 is 1 where object is placed. This is the object. I am looking from here. Object is here. So N2 is object placed where? N2. N2 and N1 value changes, right? So N1 from where you are looking. So it is 4 by 3. What is the original depth? 36 now. Apparent depth I don't know. So apparent depth is equal to 36 into 4 by 3. 12 48. So apparent away because it's a rarer medium, 48. So how far the fish see? So fish seeing the bird. Fish seeing the bird is 24 plus 48. 8 into 4 plus 1, 6. Correct? என்ன எப்படி 60 ஒன்னும் கால்குலேஷன் மிஸ்டேக்கா? அதான் n2 ன்னு சொல்லும்போது where object is placed அதான் n2. அதனால ഞാൻ n2 is the object placed. This is so object bar I. Add this points to your notebook. N2 means object, n1 means I, so depends upon the placing of object. I is here, object is here. For 72 centimeters. The next question. A man sitting. A man is sitting on a water cave. A man is sitting on a water cave. On a water cave, and a fish and a bird seeing the man. And seeing the man, how far away? How far away? Looking here, this is air, this is water, then again air. So it's a layer, right? 2 or 3 or 3 layer. How to do this kind? This is like a composite structure, right? So far we have seen. That's all. Or something else may come. So how to do this one? So listen carefully. So it is like a 2-step process. 2-step process means this is the location of I, right? We have to solve this problem as a 2 parts. Okay. So earlier this man is sitting here. You are in the man. So you are looking through water to the air. This is structure. So to do this problem, first step, 2 steps has to follow. The first step, first listen, then you can write. First step, say to do this problem, what you have to do means, assume I object. So so to observe the object, we have to split the problem as two parts. Correct. This is the first part. This is the step 1. This is the first step. First listen, then you can write later. I will give you the time. First step. So what is the original depth here? You assume you are looking from here. 10. 10 means this one is your original depth. Apparent depth you don't know. Okay. Next, I'll write the formula for this one first. N2 divided by N1 equal to original. What is N2 here? N2 is the area where object is placed. N2 is the area where object is placed. Refractive index. Where? What is refractive index? Air. 1. Divided by N1. Where you are coming? You are coming from 1.5. So 1.5. Original 10. So 10 divided is equal 15 centimeter from the surface. So now original depth is this one. Apparent depth is higher. Apparent depth equal to 15 centimeter. So you got apparent depth. Now if you are looking from here, you man is so first part is solved. Now you got. Now the next steps. You are going one more steps back. This is your step number 2. Step number 2 means this I again you remove. You again place back the normal position. This is what you want to do. Correct. Now here there are two things. Second steps. So in second steps, what to do here? I need original depth and apparent depth. Original depth in second case. Now the man is here. So from here you are, how much will come? This is 15, this is 15. Original depth you don't know. What is the refractive index? Where it is placed? Where it is placed means this is now below this one. Now you are looking from below this one. Everything it is 1.5. This is your border line. So here N2 is object. Object is where? The man is under this line. So under this line, what is the immediate refractive index? 1.5. So we'll write N2 divided by N1 equal to original depth divided by apparent depth. N2 is 1.5. N1 is from where you are looking from here. So it is, what is the original depth? 30. Apparent depth you don't know. So apparent depth is equal to 30 divided by 1.5. So 30 divided by 1.5 means 3 by 2. It is divided by 3. Answer is 20 centimeter. 20 centimeter from this first one. So from the first two, 20 centimeter down. So this is 15 plus extra 5. So this is the apparent depth. So top you see like the man is located at depth of 20 centimeter from here, and from the eye how far away? Eye is also 20. So 20 plus 20, total how much distance? 40 centimeter you feel. Should I want to explain once again? Okay, then listen once again. It is like it's a two part. Okay, how is it coming? First one, okay. Refractive index is 1.5. Here it is 1.5. Here it is 1. This is how much? 20. This is how much? 15. And man is how much? 10. Okay, this question is not like only one section, it has two sections. Why? Because you are looking from not to here, from after that also you are looking. So it has two sections. So step number 1 means you have to place your eye over here, then you have to look. Okay, so you are looking from here, an object will be here. So N2 by N1 is original depth by apparent depth. N2 is where you have placed the object. You placed the object will be here. In which medium? Air medium. So it is what? From where you are looking? You are looking from water. So this is your original depth now. So 10. Then you substituted, you find apparent depth. Apparent depth you got it as 50. So you feel like the man is located at a depth of 15 centimeters away. Now this is 15. Now first part is over. Now you got the image. Next we'll again one step back. Now you placed the eye on the original position, the previous one. So now how what is the original depth? This 15 plus this is how much? 15. So totally 30. 30 is your original. So original depth by AD. So from where you are placed? You are placed, now you are looking from here. So this is your border line. So under this border your refraction and air refractive index is the denominator 1. Apparent depth you calculated 20 centimeter. So you got from here it is at a distance of 20 centimeter down. So from the eye, how far away? Here also another 20. 20 plus 20. 40 distance away from eye you are seeing the man is located. Understood? Understood or not? Understood? Okay. Right.
We are not using that 15 centimeter anywhere.
We are using that 15 centimeter here. Why? Because here I am getting this apparent depth, right? Original depth means from here, that is your original of the next one. Okay. Actually what is happening here? See, this is water and this is air. So light is coming and undergoing a refraction. This is an object. This object create an image here, and this image is an object for this interface. This is an interface. Interface means border between the two medium. Okay, so this transition or this refraction create an object here and an image here. This image will act as an object for this interface, and this will create the final image will be here. So object, first image, second image. Understand? Confuse out, nothing to confuse, it's straightforward. Find the apparent depth from the eye. Find the apparent depth from the eye. Take your time and do it step by steps. മൂന്ന് മീഡിയം, എയർ, ഗ്ലാസ്, വേറെ ഏതോ ഒരു മീഡിയം. Step by step thing. How we will start first? Eye has to place where? Which medium I have to place my eye? So glass will place it. I am looking from here. Okay, അതിൽ ഒരു apparent depth കിട്ടും. That will contributing to the original depth for the final position. Step ആയിട്ട് draw the diagram so that you get the answer. Step ആയിട്ട് draw. This is a question. Then draw a question. Draw a separate diagram. Just object area 20, 30 mark here. Eye has to place it at this glass area. Then you are looking. Then you will apply the formula. Then you got apparent depth. ഈ ഡയഗ്രത്തിൽ ഇങ്ങനെ റൊട്ടേറ്റ് ചെയ്ത് പോട്ടാലും ഓക്കെ. Okay, now this is giving you an horizontal. I want to confuse. No need to confuse. Zero. 8 இப்போ 30 எங்கே போய் எவ்வளோ 80 ஓகே ஸோ மெஜாரிட்டி 80 இப்போ சம்திங் ராங் வித் தஸ் தேவாம்பு 100 ഓക്കെ 4 ഓപ്ഷൻസ് ആയി 50, 80, 100, 160. Breathe, come on, breathe. சொல்லுங்க. Step by step dying. Okay. Sabari, which club you are coming? 80, 100, 160? 100, option C. Ninga? 80.
Only doing
okay. 100, எவ்வளோ 100 எவ்வளோ ஜெயஸ்ரீ எவ்வளோ 100 ஓகே ஸோ வில் see so I am considering the eye over here. Step 1 considering eye over will be here. So I am writing for this step 1. Step 1, how will I write? N2 divided by N1 divided by apparent depth. N2, where the object is placed. Depth 20. is equal to 20 into 1.5 means 3 by 2. So 10 into 3, 30. So now this looks like here the apparent depth is equal to 30 here from the surface. Now I am looking from here. Here I have totally how much will be here. This is my border line. Okay, and this is another 30. So I am looking from here. I am looking from here. This is at a distance of 20. So this is just like a dotted line. So this is my step 2. Step 2. So I am going to steps. N2 divided by N1 equal to original depth by apparent depth. N2, where object is located. Object is located, this is a border line. So it has become 1.5. N1 from where this medium 2 is equal to original depth 30 plus 30 60 by apparent depth. So apparent depth into 3 by 2 is equal to 120. Apparent depth is equal to 120 divided by 3. So 240 divided by 3, answer is 80. Wait, I'll answer. So here this will be feeling at a height of 80 centimeter. From the eye means extra 20. Okay, so the eye 80 plus 20 is equal to 100. Okay, maybe some of you have forgot to add 20, right? Some of you forgot to add 20, that's what you got 80.
Sir, apparent depth is surface la idu varikku sir apparent. Yes, yeah, idhula add pandrom sir.
We are not adding depth on apparent depth. Adu kuda adinte gap ആണ് 30, extra വരുന്ന 30.
Apparent depth na surface la evlo irukku?
Surface la വരുന്നതാണ് apparent depth. That apparent depth with the extra that 30 will add and give the original depth for the second step.
Sir, adella sir. The apparent depth, the eye sees the object at irukku sir. Eye illama only apparent depth 80 only will come sir. From not from eye.
Correct. Eye illama kettina apparent depth 80 thavara.
Find the apparent depth from eye nala eye ilinde apparent depth
vare.
Eye illama only apparent depth ketta 80.
Eplume eye na kekudhu normally from where you are seeing. Okay, we'll do one question. Find the distance between the object and find the distance between the object and the final image. Draw the diagram also. You will answer, huh? Okay. Huh? Okay, try. Okay. Try சொன்னதே ஒரு கான்ஃபிடன்ஸ் தான். கரெக்டல்ல? இல்லைன்னா நார்மலி எப்படி இதே மாதிரி கொஸ்டின் ஆப்டிக்ஸ் பார்த்தா அப்படியே அடுத்த பேஜ் போயிடும். கரெக்டா? அதானே ஒரு காமன் டெண்டன்சி. பெரிய இந்த மாதிரி கொஸ்டின் இருந்தால் அது கூட ஒரு பேராகிராஃப் இருக்கும். இப்போ வாட் எவர் ஐ டோல்டு தே வில் மேக் இட் என்ன ஆக்ஸ்ஃபோர்ட் டிக்ஷனரி இங்கிலீஷ். கரெக்டா? அப்போ அதே மாதிரி சொல்லும்போது அது ஒரு 4 லைன் இருக்கும். ஒரு டயக்ராம் கூட பார்க்கும்போது ஐயோ டக் அப்போ ഏതാ കണ്ടിട്ട് ഷിഫ്റ്റ് ചെയ്യും അടുത്ത ക്വസ്റ്റ്യൻ പോകും. അതാണ് ബിഗ്ഗർ ക്വസ്റ്റ്യൻ ആയിരിക്കും ഏറ്റവും സിമ്പിൾ. സ്മാൾ ക്വസ്റ്റ്യൻ ആണ് ഏറ്റവും ട്രിക്കി. ബിഗ്ഗർ ക്വസ്റ്റ്യൻ ദിസ് ക്വസ്റ്റ്യൻ വിൽ ഹാവ് സം ട്രിക്കിനെസ് ബട്ട് യു ക്യാൻ ആൻസർ. ട്രിക്കിനെസ് കേട്ടാൽ ഇതുവരേക്കും പഠിച്ച കോൺസെപ്റ്റ് ഇതാ. ഇതിൽ 2 കോൺസെപ്റ്റ് ഉണ്ട്. അപ്പാരന്റ് ഡെപ്ത്, റിയൽ ഡെപ്ത് പ്ലസ് കോൺകേവ് മിറർ. അതാണ് ക്വസ്റ്റിൻ്റെ സ്പെഷ്യാലിറ്റി. இப்போ കോൺകേവ് മിറർ தெரியுங்களான்னு செக் பண்ணலாம், அப்பாரண்ட் டெப்த் ரியல் டெப்த் தெரியுங்களான்னு செக் பண்ணலாம். You some idea? You will try. Okay. Okay. Just a spherical structure like glass slab another 45 centimeter വരുന്നത്. You will do. I'm not telling. I'll tell you a small hint. Of course you know. ഇതൊരു ഗ്ലാസ്, ഇതൊരു ഇത്. കറക്റ്റാ? Anyway object is here. Okay, so you want to find out the distance between object and image. Okay, object is here means if you are looking from here, by default we are assuming. So this is one interface. This is the next interface. One interface is just a glass. So anyway some refractions will happen here, will be here. So here you have to find out something called apparent depth. Here you have to find, using some concept, here you have to find apparent depth. That apparent depth positions will act as object for concave mirror. Then you have to find image. Now image is a certain distance. So distance between object and image calculate. That's an idea. Simple. I can step to that. Okay, let's start. So before going to the question, I have to say one thing. We told like eye position, right? Eye is actually catching incident. For example, I can see you. Why? Because the light is coming. So my eye is receiving the refracted ray, incident ray. So here, this is an object. Okay, here in this question the speciality is like that object and eye both are in the same position. Object is here, eye is also in the same position. You can assume eye will be here. How means, for example, this is a object. This object will create an incident ray, and after refraction it is bending towards the normal, for example. Okay, not bending away from the normal, bending towards the normal. So if this is the normal ray, then this ray is supposed to go like this, but it is bending towards the normal, right? So you can assume in this case the eye has to catch the refracted ray. So here it is a 2 steps. One is a concave mirror and one is a plain glass. Okay, so here you can consider the first eye positions will come like this. This is just an assumption. I will not be there in the glass. Okay, this is an assumption only. Now we'll apply the original depth and apparent depth concept. What is the formula for original depth divided by apparent depth? N2 means where object is placed. Object is placed will be here. Air means 1. So 1 from where I am looking? imaginary steps I will be here. This is 1 point is equal to original depth by apparent depth. Original depth is this much, correct? 10. Apparent depth 10 into 1.5, which is equal to 15 centimeter. So it's over. Centimeter means what? Centimeter from here. So from here, this is now the image I can say image. This is at a distance of 50. Now the next concave mirror. Concave, this is a refraction are happening. Here what will happen? Depth constant. Apparent depth, original depth, correct? There is no apparent depth and original depth in refraction. Yeah. This is reflection. Considered as the object u equal to minus 60 centimeter. Object is this I. Okay. So now the thing is like here. What is happening? No apparent depth, no AD OD concept, no apparent depth, original depth concept. So 1 by F equal to 1 by U plus 1 by V. F concave mirror negative 1 to 1. Okay, just take it to the left hand side, so it become V equal to minus 30. V equal to minus 30 means from the so image. So now this is the first object, first image. Now this is the second image, I2. Of how much? 30 centimeter. Minus means left side. Okay. Now here I have considered this. Now this is the image. This image will act as an object for again for this interface. Adutha rotation variyana. Understood? This object, this interface, this image. This image is an object for this mirror, and this will create an image I2. Again, I2 will act as an object for this interface because I is still here. Now I am looking from I. So object is how far away from here? 30, 15. Now this is the original depth. Now will I again tell me, N2 divided by N1 equal to original depth by apparent depth. What is N2? N2 is a position where object is placed. Now this is object. So object is how far away? N2 is how much? 1.5. N1, where I am looking? 1 is equal to original depth 15. Apparent depth, I don't know, I have to calculate. So apparent depth is equal to, tell me, apparent depth is equal to 15, apparent depth into 15 divided by 3 by 2. So 30 divided by 3, 10. 10 from where? 10 from here, correct? 10 from here. To what direction? This is the original depth, so 10 from here. So only this, 10. Now here the final image I3. Now I3 to object distance is how much? Object is already how much distance away? 10 plus 10. How much? 20. My 3, that's all. So step 3 has also considered final difference. But after this is it's done, that is well and good. Step 3 obviously will miss. So now കാരണം I is still here. I is still here. അപ്പോൾ ഈ I ക്രിയേറ്റ് റിഫ്രാക്റ്റഡ് ഇവിടെ വരുമ്പോൾ സെക്കൻഡ് I ആവും. പിന്നെ I ആകുമ്പോൾ ഇത് കോൺകേവ് മിറർ പ്രോസസ് ചെയ്യും. അത് ഇതിന്റെ ഇമേജ് ആക്കും. ആ ഇമേജ് ആകുമ്പോൾ ആ ഇമേജ് വിൽ ആക്ട് ആസ് ആൻ ഒബ്ജക്റ്റ്. ഹി വിൽ ബി ഹിയർ അഗൈൻ ഫോർ the I. Good, right? Complex. Measure the object. இதே மாதிரி क्वेश्चंस இருக்கும் क्वेश्चन பேப்பர்ல நான் நேத்து சொன்ன மாதிரி ஒரு 5 to 6 क्वेश्चंस இதே மாதிரி இருக்கும் ட்ரிக்னஸ் உள்ள இருக்கும் அது ஆன்சரபிளான ஸ்கோர் 600 gross definitely we have to answer JEE advanced இதே model questions is very common because they have to write the steps அது கொஞ்சம் கூட காம்ப்ளெக்ஸா இருக்கும் I mean இரண்டான அதே மாதிரி வெச்சிட்டு அதே மாதிரி இருக்கு but idea അങ്ങനെ step ஆயிட்டு பண்ண this is understood right clear I3 will be there I3 is a final image I already I2 is what I2 is the created by concave mirror so I2 I already got the contribution from concave mirror now concave mirror given I2 will act as an object for this interface so for this because of this I2 ഈ ഒരു interface consider பண்ணி I calculated I3 so once I calculate adinte rule mudu suppose if you got I2 you can also think like okay I2 is an object for this one you can also do like that right? You can't do like that one thing is like consider for one object its rule is over adu eppadi solunga first you will interface ninga consider panni idukku appuram idu create ഈ ഇന്റർഫേസിന്റെ റോൾ ഈസ് ഓവർ പിന്നെ അതൊക്കെ തിരിപ്പി വീണ്ടും കൺസിഡർ பண்ணினா அது நியூക്ലിയർ ചെയിൻ റിയാക്ഷൻ மாதிரி இருக்கும் കൺസിഡർ பண்ணக்கூடாது സോ അത് முடிஞ்சு അത് ഓവർ ഇനി ഈ ആണ് ഇതിന്റെ ഒബ്ജക്റ്റ് ഡിസ്റ്റൻസ് അതാണ് 60 സെന്റിമീറ്റർ അപ്പൊ കോൺകേവ് മിറർക്ക് പോയി കോൺകേവ് അത് ഫസ്റ്റ് ഇത് ക്രിയേറ്റ് ചെയ്തു ഇത് I1 ക്രിയേറ്റ് ചെയ്തു I1 ആണ് ഈ കോൺകേവ് മിററിന്റെ ഒബ്ജക്റ്റ് ആ ഒബ്ജക്റ്റിനെ പ്രോസസ് ചെയ്ത് this concave mirror created an image I2 you can't again consider I2 is an object for concave mirror no you can't consider like correct you can't consider like that because I2 is given by processing the concave mirror process to I2 കൊടുത്തു then I2 will come here then I2 is going to process by this interface again once this interface is processed you are getting I3 you are not going to process it again and again and again no only one time ഒരു ഒബ്ജക്റ്റ് വെച്ച് അത് I1 ഇമേജ് ഉണ്ടാക്കി ഈ I1 in the mirror what will act as it will act as find out I2 okay I2 യൂസ് பண்ணி ഈ ഒരു ഇന്റർഫേസ് വെക്കുമ്പോൾ we got I3 അവർ തിരിപ്പി കേൾക്കുന്നത് I3 can I consider no because I already considered I2 then only I got I3 if you consider I3 again then you will get consider I4 again then you will get it will continue like that will never happen only one ഫിനോമിനൽ യൂസ് ചെയ്യുന്നത് ഇത് ബേസ് ഈ ഇപ്പൊ കപ്പൽസ് ഷിപ്പ് അതിനെല്ലാം പാർട്സ് കണ്ടുപിടിച്ചത് ഈ മെത്തേഡ് യൂസ് ചെയ്യുന്ന ഇതേ മെത്തേഡാണ് ഫ്ലൈറ്റിൽ യൂസ് ചെയ്യുന്നത്, ഓട്ടോ പൈലറ്റ്. കാരണം ഫ്ലൈറ്റിന് ടേക്ക് ഓഫും ഫ്ലൈറ്റും മറ്റും അണ്ടർ ദ കൺട്രോൾ ഓഫ് ദ പൈലറ്റ്. വൺസ് ഫ്ലൈറ്റ് pilot has no control. Pilot is simply sleeping because everything is doing by radar system. Everything is doing by radar. Flat position then it will run automatically. എല്ലാം സിസ്റ്റം സെറ്റ് ചെയ്ത് we can sleep for next 5 hours. പിന്നെ ഡെസ്റ്റിനേഷൻ റീച്ച് ആകുന്നതൊക്കെ മുന്നാടി ഒരു 100 kilometers 200 അതിനൊരു അലാറം. നെക്സ്റ്റ് പൊസിഷൻ ഈസ് ഗോയിങ് ടു ലാൻഡ് ഓഫ്. പിന്നെ അത് ഇരിക്കുന്നത് 900 feet above ആയിരിക്കും. 900 അല്ല 9000 feet above ആയിരിക്കും. പിന്നെ അതിങ്ങനെ സ്റ്റെപ്പ് ആയിട്ട് ഇങ്ങനെ ഡൗൺ ചെയ്യും. അപ്പോൾ അതിന്റെ ഫസ്റ്റ് സ്റ്റേജിൽ ഇങ്ങനെ പോകും, ഫീൽ തരും ഇങ്ങനെ, ആ ഒരു എയർ പ്രഷർ ഇങ്ങനെ ഫീൽ ആവും. ഓക്കെ, ഫസ്റ്റ് ഇങ്ങനെ ഡൗൺ ചെയ്യും, എന്നിട്ട് ഒന്നുകൂടി ഡൗൺ ചെയ്യും. അപ്പൊ ഫസ്റ്റ് ഡൗൺ ചെയ്തിട്ട് ഇറ്റ് വിൽ ഗോ ഇങ്ങനെ. ഓക്കെ, സ്റ്റെപ്പ് ബൈ സ്റ്റെപ്പ് ആണ്. ഫസ്റ്റ് ഡൗൺ ചെയ്യും, എന്നിട്ട് അതാണ് മോസ്റ്റ് റിസ്ക്. ഒരു പൈലറ്റിന്റെ എക്സ്പീരിയൻസ് അവിടെയാണ് എടുക്കുന്നത്. അതാണ് മോസ്റ്റ്. അതുകൊണ്ടാണ് മോസ്റ്റ് അത് ഈ ലാൻഡിങ്ങിലായിരിക്കും. ഓക്കെ, കാരണം ലാൻഡിങ് ഭയങ്കര പെർഫെക്ഷൻ വേണം. ഭയങ്കര പെർഫെക്ഷൻ എന്ന് പറഞ്ഞാൽ ആ കറക്റ്റ് വീലാണ്. ഗാന്ധിപുരത്ത് ട്രാഫിക് പോകണം, സിഗ്നലിങ് കിട്ടണ ഇറ്റ്സ് വെരി ഹെക്ടിക് ടു റൈറ്റ്. അപ്പൊ അത് മാതിരില്ലല്ലോ. ലക്കിലി ഇങ്ങനെ സംഭവം സെറ്റൻ ഇതെല്ലാം അയ്യോ ജസ്റ്റ് മിസ്സായിരിക്കും മിക്ക. Safety is the most important because something happens, last thing in your life. Correct alla? No return back. Okay, something happens, that's the last thing you are going to see. There is very less chance. ഈ ലാൻഡിങ് ഭയങ്കര പെർഫെക്റ്റ് ആകുമ്പോൾ ഈ മെത്തേഡ്സ് എല്ലാം ഇപ്പം ഇതിലിപ്പോൾ ജസ്റ്റ് വി ആർ ലേണിംഗ് അബൌട്ട് ക്ലാസ്സസ്, ബട്ട് റൈറ്റ്. അപ്പൊ ക്ലൗഡിന് ആ ഒരു എയറിന്റെ wings of the flight, there is some flap will be there which can be adjusted. ഒരു flap അത് അഡ്ജസ്റ്റ് ചെയ്യുന്നത് ചെയ്യാനും എയറിന്റെ ഡെൻസിറ്റി ബേസ് അതെല്ലാം ഭയങ്കര ഒരു ലോവർ എന്ത് വരുമ്പോൾ ബേർഡ്സ് ഒന്ന് ഹിറ്റ്, അത് ഭയങ്കര സ്ട്രോങ് ആയിരിക്കും. ഈ സോ അത് തമിഴ് എന്നാ എനിക്ക് തരില്ല, മലയാളത്തില് ദേശാടന കിളികൾ എന്ന് ചൊല്ലും. മീൻസ് they will Tamil, these birds are the migrant. അതിങ്ങനെ ഗ്രൂപ്പ് ആയിരിക്കും, ഓരോരോ ക്ലൈമറ്റ് ചേഞ്ച് ചെയ്യുമ്പോൾ ഗ്രൂപ്പായി ട്രാവൽ ചെയ്യും. ആ മൈഗ്രേറ്റ് തരും, ബട്ട് ആയിട്ടായിരിക്കും വരിക. വരുമ്പോൾ അതെല്ലാം ഭയങ്കര ഫോഴ്സ്ഫുൾ ആയിട്ട് ഇതിന് ഒന്ന് അടിക്കും. ഓക്കെ, അതിന്റെ കൗണ്ട് എന്ന് പോകുന്ന ഒരു 200 to 300 ഒരേ ഷോട്ടിലും അതേമാതിരി എല്ലാം വന്നിട്ട് അതൊരു ആക്സിഡന്റ്. അങ്ങനെ ഫ്ലൈറ്റിനെ So അതൊരു ആക്സിഡൻ്റ് ആയിട്ട് മാറും most of the. There are a lot of accidents are there in like many years. അവിടെയാണ് ഒരു പൈലറ്റിനെ, കാരണം ഈ ഒരു ബേർഡ്സിൻ്റെ ഗ്യാങ് വരുന്നതിന് ഒരു പർട്ടിക്കുലർ പാറ്റേൺ ഉണ്ട്. ആ പാറ്റേണിലാണ് അതിങ്ങനെ ഫ്ലോ ചെയ്യുന്നത്. അപ്പം ദ പൈലറ്റ് ക്യാൻ ഈസിലി അണ്ടർസ്റ്റാൻഡ്, കാരണം ദർ ഇസ് നോ റോഡ് ഇൻ ഫ്രണ്ട് ഓഫ്, റൈറ്റ്? നത്തിങ് വിൽ ബി ദർ. ഇറ്റ്സ് പ്യുവർലി എ വൈറ്റ് ഏരിയ. സോ ഏത് റൂട്ടിൽ പോകണം എന്നുള്ളതെല്ലാം റഡാറാണ് കാണിക്കുന്നത്. ഇപ്പോൾ റഡാർ വിൽ ഓൾവേസ് മെഷർ ദ ഡിസ്റ്റൻസ്. യു ക്യാൻ തിങ്ക് അബൌട്ട് ഇപ്പോൾ ഒരു 9000 ഫീറ്റിലിരുന്ന ഗ്രൗണ്ട് ലെവലിന് 9000 ഫീറ്റ് ആണെന്ന് എപ്പടി തിരിയും? ദർ ഇസ് നോ സ്കെയിൽ ടു എപ്പടി തിരിയും? അതാണ് അവിടെയാണ് ഈ ഒരു റഡാർ സിസ്റ്റം. കാരണം അവിടെ വാട്ട് എവർ യു ജസ്റ്റ് ലൈക്ക് ആൻ അപ്പാരന്റ് ഡെപ്ത്. ഒറിജിനൽ ഡെപ്ത് ഈസ് നോട്ട് ലൈക്ക് ദാറ്റ്. ഓക്കെ, അതുകൊണ്ടാണ് there are ഇപ്പം I don't know you know or not, when my childhood days I have seen one big accident വെച്ചാൽ ഇന്ത്യൻ പെസിഫിക്കിൻ്റെ മേലെ വന്നൊരു ആക്സിഡൻ്റ് ആയിരുന്നു. അതൊരു ഇറ്റ് ഈസ് എ വെരി ലൈഫ് സേവിങ്. 600+ passengers are saved the life. കാരണം ഫസ്റ്റ് ഫ്ലൈറ്റ് നിൽക്കുമ്പോൾ ആ ഫ്ലൈറ്റിന് 3 എൻജിൻസ് ഉണ്ടാവും. ടോട്ടലായിട്ട് 3 എൻജിൻ. ഒരു എൻജിൻ ഫിനിഷ്ഡ്. അപ്പോൾ അതിൽ ഈ 2 എൻജിൻ ഫെയിലായി. 2 എൻജിൻ ഫെയിലായ 3ാമത്തെ എൻജിൻ ഫെയിലുള്ള ചാൻസ് ഭയങ്കര അധികമാണ്. ഒരു എൻജിൻ ഫെയിലായാൽ വലിയ റിസ്ക് ഇല്ല, കാരണം മേ ബി സംതിങ് എൽസ് ഈസ് ഹാപ്പണിങ്. 2 എൻജിൻ ഫെയിൽ ആയാൽ അതൊരു കോമൺ പ്രോബ്ലം ആയിരിക്കും. അപ്പോൾ അത് ഭയങ്കര റിസ്ക് ആണ്. പിന്നെ ഒരു എൻജിനിലാണ് ആ ഫ്ലൈറ്റ് ഓടണം, അതുകൊണ്ട് ഫ്ലൈറ്റ് എടുക്കും. ആ 3rd എൻജിനും ഫെയിലായി. ആ 3rd എൻജിനും ഫെയിലായപ്പോൾ ആ ഫ്ലൈറ്റ് നിൽക്കുന്നത് 5000 ഫീറ്റ് എവേ ആണ്. 5000 ഫീറ്റ് എവേ ആണ്. അതിപ്പോൾ യൂട്യൂബിലൊക്കെ ആ വീഡിയോ ഭയങ്കര വൈറൽ വീഡിയോസാണ്. 5000 ഫീറ്റ്സ് എവേ ആണ്. അപ്പോൾ 5000 ഫീറ്റ് എവേന്ന് ഈ ഫ്ലൈറ്റിന് പൈലറ്റിൻ്റെ so then this air hostess will announce to put the jackets, right? Okay, our jackets place ചെയ്യുന്നത് അത് 2 റിസ്ക് 2 ഇതിലാണ്. Normally they will see a lot of actions. Nobody will care what they're telling. Nobody. Okay, but they'll tell you, I mean, safety is most important there. അപ്പോൾ air hostess will say like everybody has to put the seat belt. They will announce it, and so people will be getting nervous, right? Something is going to happen. അതേ മരുന്ന്. So they know what is happened. 3 എൻജിൻ ഫെയിലായി and fire is started to come on both wings. അപ്പോൾ ഇതിങ്ങനെ നല്ല ഹൈ പ്രഷറിൽ പോവാണ്. അപ്പോൾ എന്തായാലും ഫയർ വരുമ്പോൾ ഫയർ വിൽ ബി ഗെറ്റിംഗ് ഡബിൾ ആൻഡ് ഡബിൾ. കാരണം ആ എയർ അല്ല, അതിങ്ങനെ ഭയങ്കര എയർ. So flight double. So only option is in front of him is the Pacific. Okay, അപ്പോൾ ഈ ഫ്ലൈറ്റിന് ഒരു ഓപ്ഷൻ ഉണ്ട്. ഫ്ലൈറ്റ് ക്യാൻ ലാൻഡ് ഓൺ വാട്ടർ. ഫ്ലൈറ്റ് ക്യാൻ ലാൻഡ് ഓൺ വാട്ടർ. അതൊക്കെ ചില മെക്കാനിസംസ് ഉണ്ട്. ദ പൈലറ്റ് നോസ്. ഒരു കേസ് വന്നിനാ ഫ്ലൈറ്റ് വിൽ ഡാമേജ് ബട്ട് ലൈഫ് ക്യാൻ സേവ്. ഫ്ലൈറ്റിൽ അത് കറക്റ്റായിട്ട് ഒരു പർട്ടിക്കുലർ ഒരു ഓറിയൻറ്റേഷൻ്റെ അത് ഫ്ലൈറ്റിൽ ആ വാട്ടറിൽ പ്ലേസ് ചെയ്താൽ ഇറ്റ് വിൽ ഫ്ലോട്ട്. ബോട്ട് ഇരിക്കണം അതേമാതിരി ദിസ് വിൽ ഫ്ലോട്ട്. ആ പൈലറ്റിൻ്റെ ഇൻ്റലിജൻസ് ആണ്. ഇറ്റ് വിൽ ഫ്ലോട്ട് ഇൻ വാട്ടർ. ഓക്കെ, അപ്പം അതൊക്കെ അതിൻ്റെതേ മെക്കാനിസംസ് ഉണ്ട്. നോർമലി യു ഹാവ് സീൻ ലൈക്ക് വളരെ ലോ എൻഡ് ഫ്ലൈറ്റിലെല്ലാം യു ഹാവ് സീൻ സം വീൽസ് ഇങ്ങനെ ഉണ്ടോ, അങ്ങനെ കാണുന്ന വീൽസ് ഉണ്ട് സൈഡിൽ. ഓക്കെ, ആ വീൽസിൻ്റെ റൊട്ടേഷൻസ് അത് കീഴെ വെച്ചിട്ട് ദാറ്റ് വിൽ അതിങ്ങോട്ട് റൊട്ടേറ്റ് ആയി കഴിഞ്ഞാൽ ഈ ബോട്ടിലുള്ള മോട്ടർമാർ അതിങ്ങനെ റൊട്ടേറ്റ് ആയിട്ട് ദിസ് വിൽ ഓൾവേസ് ഫ്ലോട്ടിങ്. അതാണ് അത്. ബട്ട് ഈ കേസിൽ എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ ഫാൻ ഈസ് റൊട്ടേറ്റിംഗ്, ഓൾ എൻജിൻസ് ആർ ഗോൺ ഔട്ട്. ഓക്കെ, അപ്പോൾ ഈ ഒരു അതാണ് യൂട്യൂബിൽ ഇതിൻ്റെ വീഡിയോ ഉണ്ട്. ഭയങ്കര ത്രില്ലിംഗ് ആയിരിക്കും. പൈലറ്റിൻ്റെ കോൺഫിഡൻസ് ആണത്. ഓക്കെ, കറക്റ്റായിട്ട് അത് ആ പെസിഫിക്കിൽ അങ്ങോട്ട് ഫ്ലോട്ട് ചെയ്യിപ്പിച്ചു. കറക്റ്റായിട്ട് nobody has no single injury. But specifically அதுக்கப்புறம் lot of like CNN நியூஸ் சேனல் எல்லாருமே இன்டர்வியூஸ் എടുക്കുന്ന ടൈമിൽ വാട്ട് ഹി ടോൾഡ് ലൈക്ക് വളരെ ഭയങ്കര സയൻറ്റിഫിക് ആൻസർ ആയിരുന്നു പൈലറ്റിന്. അതായത് he has 50-50 chance. Either everybody will die, that is one chance. Either he has to do his best. Sometimes it will get saved, sometimes it will go out. So save your chance ഭയങ്കര. Okay, save your ഭയങ്കര chance ഇല്ല. But he told 600 life is on my hand. 600 life is on his hand, so he has to do something. But what he told, then first engine fail ആയി, second engine fail ആയി, third engine fail ആയപ്പോൾ immediately we know everything is going to clash. അപ്പോൾ അവർ കേട്ടു anyway it is Pacific, it's a big area, you cannot you are very sure that you cannot Pacific at this condition. And Pacific avlo length il kidakkana 100% ee engine conditions vechittu you cannot cross the Pacific. Then you can take as much as possible land off. Actually, evlo faster you can take the landing. Why you traveled again 1050 kilometers? After he traveled 1050 kilometers only, he take the landing. So once you see the fire, immediately you can take the landing. Why you have kept like 1000 kilometer, you again run it, then the fire will be very high and flight many damage will be happen. Why you take? He told this concept will be there. Why? Because he told when the flight will be there, the depth to the underwater sea, okay, from the sea surface there is a depth will be there. The depth is very, he told it's very high. Yeah? And using the radar technology, he understand that there are a lot of ripples, water ripples adhigarno. So our area flight definite item our ripple varuma water la flow water la sustain panna mudiyadu kata just adu down ayi po appo water la ingane correct aayittu float cheyidu nikkadukku water inde disturbance kammi ulla area ene podanam kettalla illane water high disturbance irukka koodadu appo water disturbance also he measured using the technologies available in the flight when he is at the risk. And our risk we are all nervous. ആ ഒരു വാട്ടറിന്റെ ഡിസ്റ്റർബൻസ് മെഷർ ചെയ്തു, ആ വാട്ടറിന്റെ ഡെപ്ത് മെഷർ ചെയ്തപ്പോഴാണ് he didn't put the flight on water, he again traveled ഫ്രണ്ട്. അങ്ങനെ ഫ്രണ്ട് ട്രാവൽ ചെയ്ത് ഒരു മോസ്റ്റ് സ്യൂട്ടബിൾ, അതുവരേക്കും കണ്ടതിൽ മോസ്റ്റ് സ്യൂട്ടബിൾ എന്ന് തോന്നുന്ന ഒരു പൊസിഷൻ വന്ന ടൈമിലാണ് he just tried to land the flights എന്നുള്ളത്. അപ്പോൾ അവിടെ ഇന്റലിജൻസ് ആണ്, നത്തിങ് എൽസ്. കാരണം 50-50 ചാൻസ് ആണ് പോകൾക്ക്, കേട്ടാ. അപ്പൊ അതാണ് ഇതിന്റെ അപ്ലിക്കേഷൻ. കാരണം എയർ ആണ്, അത് കഴിഞ്ഞ് വാട്ടർ ആണ്. അപ്പൊ ഇതെല്ലാം യൂസ് ചെയ്യുന്ന റഡാർ ടെക്നോളജിയാണ്. ഈ റഡാർ പൾസ് இதுதான் they are measuring. കാരണം റഡാർ சொன்னது இப்போ நம்ம இங்க பேന വെച്ച് കാൽക്കുലേറ്റ് பண்ணி ഇടണം, അതേ മെഷർമെന്റ് ആണ് റഡാർ ഈസ് ഡൂയിങ്, ബട്ട് ഇൻ ടേംസ് ഓഫ് കിലോമീറ്റേഴ്സ്. ആ ഒരു മെഷർമെന്റ് കറക്റ്റ് നമുക്ക് ആ റഡാർ ആ ഇൻഫർമേഷൻ has to given, then only we can take a wise decisions. Okay, just I told, we'll go to next topic.